All right, so here we're going to start section 6.4, part 1. This is going to be a two-part video. We're still talking about conic sections, and we're actually going to talk about the third of 4 that we're going to do this chapter, called hyperbolas. And if you notice, hyperbolas they look like double parabolas. Okay, so this is an example of what you're going to be able to graph in about 5 minutes here. So they're not really that hard. They're very similar to the ones that we've been doing. So let's get right into it. All right, so we're going to start with the equations of hyperbolas. And if you notice, they're very similar to what we've already done. Okay, but notice there is some differences. Hyperbolas have a minus sign in between the x squared and the y squared. So the ellipses had pluses, hyperbolas have subtraction signs. They're still equal to 1. Okay, so they still need to be equal to 1. But notice where the a is. The a is always in the front. Okay. So that's one thing that we have to jot down about hyperbolas. A is always the first number on the bottom. On the bottom. Okay. Now, when we talk about ellipses, remember A was always the biggest number on the bottom. Now A is always the first one. So no matter if it's the smallest or biggest, it's always going to be the first one. Okay. We have some asymptote equations. Okay. So the easy way to remember these is whatever comes first in your equation. So if x squared comes first, this is the one you're going to use. And if y squared comes first in your equation, this is the one you're going to use. And we'll talk more about that when we actually do some examples. Now the bottom equation should look familiar as well. It's c squared minus a squared for hyperbolas. The only difference is this was switched for ellipses. Okay, so we switched the c and the a when we're talking about ellipses and hyperbolas. They just flip-flop. Okay, so we're going to use all these equations, which are very similar to the ones we've already done for ellipses, to do some hyperbola examples. Now, must remember, hyperbolas always have a subtraction sign. Okay, so we just talked about that. Hyperbolas have a subtraction sign, and a is always first. Okay, so those are the two things that we kind of just briefly mentioned on the last slide. All right, so basically what we're going to do is we're going to do 2 examples, and then we're going to graph them. All right, so we're going to do these the same way that, oops, wrong mark. All right, so let's figure out our A, our B, and our C. All right, so A, remember A is always the first number on the bottom. So this is A squared. So the square root of 9 is 3. And what letter is it underneath? It's underneath X. B is always the second number on the bottom, and it's underneath Y. So it's going to go on the Y, and the square root of 25 is 5. So what we need to do now is we need to be able to figure out C. Okay, so for hyperbolas, it is B squared equals c squared minus a squared. All right, so b squared is 25. C squared we don't know. Minus a squared is 3 squared is 9. So I'm going to add 9 to both sides. So add 9. C squared equals 25 plus 9 is the square root of 34. Okay, so I can get rid of my power of 2 because I already took the square root. So C is the square root of 34. Let's figure out what that is as a decimal. Square root of 34. It'd help if I was on the right screen. Square root of 34 is 5.83. Okay, 5.83. And remember, A always goes with C. So if we're on the x-axis for A, we're going to be on the x-axis for C. Okay, I'm going to get rid of this right now. We don't need this anymore. All right, so this is what we're going to do. We are now going to graph this hyperbola. All right, so we do this basically. Now this is a little bit different. It's very similar, but it's also very different at the same time. All right, so what we're going to do first is we're going to take our A value, and it's on the x-axis. We're going to put a dot at 3 to the right, and we're going to go 3 to the left. Okay. We're also going to do our B. Now B is 5, and our negative B is negative 5. Okay, so I'm going to mark this A, negative A, positive B, negative A. Now remember, A doesn't always have to be the biggest anymore. Okay, we're going to save C for last. All right, now this is the part that's different. We're going to draw a rectangle, an imaginary rectangle through our A's and our B's. It's a little bit harder to do on the computer, but I think you get the picture. All right, so here's our imaginary rectangle. Okay, those are going to be the boundaries of our hyperbola. Now, hyperbolas have lines of asymptotes, and they go through the origin up through each corner. Oops, I'm not doing a very good job drawing these through the corners. Okay, so those are our, let me move these a little bit better. Alright, so these are a little bit closer now to the corners. They should go right through the corners of your rectangles. Alright, now those are lines of asymptotes. Now, we have enough information now to draw our hyperbolas. Okay? So we always draw them through the A values. Okay, so our A's are on the x-axis. So these green lines are our boundaries. We cannot cross those green lines. Okay, don't forget your arrows. Okay, so there is our hyperbola. Now, once again, this is very difficult to draw on the computer, so I'm trying to do my best and keep it as neat as possible. Okay. Now, let's put our C's in now. We haven't put our C's in, so let's do that. Our C's are at 5.83, and they're on the x-axis, so I'm going to go to 5.83. And now C's don't necessarily have to be inside of your A's, so they could be on the outsides now. So there's our C's. Okay, and the last thing we need to do is we need to write our asymptote equations out. Okay, so now let me get rid of some stuff attached to here. Okay, now notice we have our equation starts with x squared. So I'm going to go back to my formulas. The one that starts with x squared, here is the asymptote equation I'm going to use. B over ax, plus or minus b over ax. So y equals plus or minus b over ax. So what's our b? Our b is 5. Our a is 3. Oops. I said 5 and I wrote b again. So 5 over a is 3. Okay, so those are our asymptote equations. These are the equations for these green lines here. Okay? So that is our asymptote equations for those imaginary green boundary lines. Those are lines of asymptote. Okay, so let's do one more, and then we'll pretty much be done. Okay, so here we go. So sketch the graph again. So we're going to need A, we're going to need B, and we're going to need C. All right, so A is always the first number on the bottom. So square root of 36 is 6, and it's underneath Y. B squared is always the second number, so square root of 4 is 2, and this one is X. And it is underneath x because that's how I know it's underneath x. And c we need to figure out. So remember, oops. All right, so it's b squared equals c squared minus a squared. B squared is 4 equals c squared, we don't know, minus a squared is 36. So I'd add 36 to both sides. Add 36. So 40 equals c squared. Square root, I get square root of 40, which is what as a decimal? Square root of 40, enter, 6.32, 6.32, and it's also on the y, so because remember, A and C always go together. Alright, so that's how we figure out C. I'm going to delete this, or erase this, and then we should be able to come up with our graph. Alright, so let's see here. Alright, our A is 6 and it's on the y-axis, so I'm going to go up 6. Let me do this in a colored. Up 6 and down 6. I'm gonna make the screen bigger for right now, so let's remember these numbers here. Alright, so we have, I apologize, I'm trying to do this as best as I can. Alright, so our A is 6, our B is negative 6, or sorry, our negative a is negative 6, our b is 2, and negative 2. Okay, so I'm going to draw my rectangle now. Okay, this rectangle gives our hyperbola its shape. Alright, and then we're going to draw our asymptote lines. Let's change it to green. Okay, so our asymptote lines go from the origin through the corner of our rectangles. I'm trying to get as close as I can to the corners. It's very difficult on the computer. Okay, better than the last one. Alright, so first off, let's remember to mark our shapes here. So A's are these now. A, negative A, positive B, negative B. Alright, now let's draw we can draw our hyperbolas now. Okay, and always remember that they go through A. Okay, so this time our A's are on the Y, so our hyperbola is going to go up. And remember, you cannot touch your lines of asymptote. Those are the boundaries. You can't touch those. Don't forget your arrowheads. Alright, so there's our hyperbola. Now the only thing we have to do is add our C values. And our C here is 6.32. And now this is an issue because my graph only goes to 6, but that's okay. So we're going to go 6.32, about right there. There's our positive C. And we're going to go negative 6.32. There's our negative C. Okay, and last thing, finally, is our lines of asymptote. Now this one, y comes first, so it's plus or minus a over bx. So our lines of asymptotes are 6 for a, our b is 2, so that reduces to y equals plus or minus 3x. Okay, and remember those are the equations of our lines of asymptotes. Alright, so that is section 6.4, part 1, the basic introduction to sketching hyperbolas. I'll see you tomorrow when we work on these a little bit more. Have a good one, and Michigan's playing tonight in the grade 8. Hope they win.